Assalamualaikum warahmatullahi wabarakatuh and good day. So, by the previous lab session, we've done our first experiment, which is experiment 1, Marcet boiler. So today we are going to present our lab report based on the lab session. So the objective of this experiment is to observe and analyze the relationship between pressure and temperature of saturated steam. From this, we aim to verify that when the pressure increases, the saturation temperature will also increase, which is consistent with the values stated in the steam tables. So as the scope, this experiment focuses on studying the behavior of saturated steam inside a Marcet boiler apparatus. In this experiment, we record the pressure and corresponding temperature at several points and plot a graph of pressure versus temperature. The experimental results are then compared with standard steam table values to evaluate their accuracy. In addition, we aim to understand the phase change process between water and steam under controlled conditions, as well as identify possible errors and heat losses that may affect the result.
Now is our theoretical part. The thermodynamic properties of a pure substance could be determined by two following characteristics, which is the temperature, pressure, entropy, and a volume. The data characteristic could be obtained either from experiment, equation, or just certain. Among of two thermodynamic properties that can easily measure are temperature and pressure. A capital equation describes the slope of a saturation line on a pressure versus temperature diagrams. Relation between these properties could be expressed in the forms of graph or equation. The equation described as follows: dT or dP on saturation line equal to temperature times change in specific volumes over change in specific enthalpy. And we assume that the specific volume of a liquid, which is water, is equal to 0. This is because the specific volume of steam is larger significant than the specific volume of water. So we simplify it, we can get dT over dP of such a line equal to the temperature times volume of steam over its specific enthalpy. So words, the Vf is volume of water, Vg is the volume of steam, Vf is enthalpy of water, and Vg is enthalpy of steam, and Vf is the heat domain of the vaporization. So next, the future is show about how experiments set out, and this machine is called about Marcet boilers. And the next features show about the components of a Marcet boilers. So number 1 is the drain valve, number 2 is heater, number 3 is overflow valve, number 4 is filter plug, number 5 is safety valve, and number 6 is the temperature sensor, number 7 is thermometer, number 8 is the boiler with an insulating jacket, and number 9 is our temperature gauges, and number 10 is the heater switch, and the 11 is the master switch.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Fatih Fajar binti Tuan Arif Saib Azmi, and I'm responsible for the methodology part. So the first one is the filler and overflow valve were open, and then the second one is the boiler was filled with water until water flow out from the overflow valve, and then the third one is the filler plug was closed and tightened using a spanner, and the fourth one is the main switch and heater were turned on. And once the temperature reached 97 to 100 degrees Celsius, the overflow valve was closed. Then the initial temperature was recorded with a 0.5 bar, and then the increase in temperature was recorded for each subsequent of 0.5 until the pressure reached 5 bar. and then the heater was switched off, and the decrease in temperature was recorded for each pressure reduction of 0.5 bar until it reached 0.5 bar, and then lastly the main switch was turned off.
So for the result part, we need to find the external pressure first. The external pressure is equal to the atmospheric pressure plus the Gauss pressure, which is 0.5 plus 1.01325 bar. So finally, the external pressure is equal to 151325 kPa. After that, we need to find the mean temperature, and the mean temperature is equal to the temperature increasing minus the temperature decreasing divided by the 2. So we need to measure the slope. Temperature slope is equal to dT over dP, which equal to temperatures times the difference between the volume of the water and volume of the steam divided by the heat tolerance of the preparation. See, this one is the table for our data operations, and this one is the table for calculation to determine the volume of the steam and the heat tolerance of the vaporization. Here we got the 3 sample calculations to determine the volume of the steam, the enthalpy of the steam, and the calculate slope. So this one is the graph for the temperature against the absolute pressures, and this one is the graph to show the average temperature against the absolute pressure. And this one is the graph 3, the slope against the absolute pressure. So I will explain a little bit about this. Show that the slope decreases as the absolute pressure increase for both pressure and the calculated value. So this indicates that the system becomes less sensitive at higher pressure. The calculated slope follow a smooth downward trend, while the measured slope show slight fluctuations, especially in the mid pressure range, likely due to the experimental uncertainties. So despite these small deviations, both curves generally cross and converge at high pressures. So demonstrating good agreement between the experimental data and the theoretical predictions. So minor difference may be caused by the instrument position limit and the temperature variations or reading error. Table 3, which show the percentage error between the calculated slope and the measured slope. So the table show the comparisons between the measured slopes and the calculated slopes and the different absolute pressures. So along with the percentage error. At lower pressure, the percentage error is small, about 1 to 4%, indicated as a good agreement between the experimental and the theoretical values. As the pressure increases, the error becomes larger and reach a maximum until 46.29% at 4.135 bar, while the measured values deviate significantly from the calculated value. After this point, the error decreases again at higher pressures, showing improvements. So overall, the results suggest that the experiment is more accurate at low and high pressures. Well, the greater display occur at my range pressures, likely due to the experimental uncertainty as well as the measurement limitations, heat loss, or the instability during the data collections.
Next, to the discussion part. As for the observation of the experiment, we can see that the water in the Marcet boiler was at approximately temperature of 99.97 degrees Celsius when after the overflow valve is closed at 97 degrees Celsius. The water molecules will get trapped inside the boiler, and the trapped molecules increase the pressure as the temperature rises. The temperature increases and the molecules gain more kinetic energy and collide more frequently with the wall of the boiler. So this leads to a rise in pressure, showing that temperature and pressure increase together and directly proportional. Looking at the graph of the average temperature versus absolute pressure, we can see that the temperature rises as absolute pressure increases. This confirms the direct relationship between the temperature and pressure of the steam. At lower pressure, the temperature will increase faster. However, at higher pressure, the temperature will still rises, but at a slower rate. As pressure increases, the temperature of steam rises, but the rate of the increase slows down. This means that how fast temperature changes or the slope of the graph will become smaller at higher pressure. So we have predicted that the slope needs to become smaller at higher pressure since we need more energy to increase the temperature. However, in our experiment, the measured slope drops a bit more than expected. This is due to some practical issues like heat loss, delays in temperature changes, or small error in reading the instruments. So while the overall of the slope makes sense physically, the extra dip is mostly caused by measurement challenges during the experiment. So, in summary, the experiment demonstrates that the steam temperature with pressure, the relationship is directly proportional and the measured trends closely match with theoretical predictions.
So for safety procedures, there are 5 safety procedures that we need to follow throughout the lab session. The first one is personal protective equipment. We need to wear a lab coat and closed-toe shoes at all times to protect against spills and hot surfaces. The second one, for the filling process, ensure the overflow valve is open during the filling process to prevent overfilling and maintain a safe water level inside the boiler. The third one is heating stage. Do not close the overflow valve until the temperature reaches approximately 97 to 100 degrees Celsius to avoid pressure build-up at an early stage. The fourth one, pressure control. Increase the pressure gradually in intervals of 0.5 bar and ensure it does not exceed 5 bar to prevent any risk of over-pressurization. And the last one is shutdown and cooling. After switching off the heater, allow the system to cool down completely before opening any valve or handling the apparatus.